Let's look at another problem. It's called a root test. Root test. The root test. All right, this root test, I'll talk about what it is in a minute, but the original problem is summing n is 1 to infinity of 1 over n plus 1, that's raised to the n power. N plus 1 raised to the n power. So now, what this root test, the root test in my textbook can be found on page 591. Page 591, this root test says all you're really doing is just taking the nth root. Take the nth root, and analyze if the limit as n goes to infinity of the nth root is less than 1. Well, that would verify convergence, actually absolute convergence. But we'll talk about that in another show. If you evaluate the limit and you get either the limit greater than 1 or infinity, that would verify divergence. And if you evaluate the limit and you would get 1, that would prove that this test is inconclusive. All right, so what I would do first is I'd rewrite this problem to get n approaches 1 to infinity, and rewrite this 1 to the n over n plus 1 to the n. All right, so what this says is you're going to take the nth root, which another way of saying take the nth root would be to raise it to the 1 over n power. All right, raise it to the 1 over n power. And what you're going to do is, I'm sorry, maybe I should have had a limit here. You're going to evaluate, sorry about that, you're going to evaluate the limit of the nth root. The limit as n approaches infinity, you're going to evaluate the nth root of this. So you evaluate the nth root, you get the limit as n approaches infinity of the nth root of 1 to the n, that's just 1 over the nth root of n plus 1 to the n, that's just n plus 1. All right? N plus 1. So you evaluate this limit, you substitute in infinity, hopefully you see that the denominator is getting incredibly large, which would enforce this fraction get incredibly small. You're going to get 0, a limit of 0. Well, according to the test that I had here earlier, if the limit of the nth root of a sub n is less than 1, that would prove that the original series converges. Converges absolutely, but it converges. Anything that converges absolutely converges. So this converges. I don't have time to put that into words because I want to get through one more example. I don't have a lot of time. I want to get through one more example. All right? So let's take a look at a problem where my student had to do this problem where they have this series. Let's see which one we can do here. Let me see if I can find. Let's do this one here. They had this problem. I hope I can finish it. As n goes to 0 to infinity of n x minus 5 raised to the n over 3 to the n. So interval, they want the radius of convergence. Radius of convergence. A lot of times when they want this radius of convergence, you're going to end up using the ratio test. And that's the test where you apply the limit as n approaches infinity of a to the n plus 1 over a sub n. So if we did that, we're going to end up with limit as n goes to infinity of n plus 1. I'm rushing a little bit because I don't have a lot of time. N plus 1 over x minus 5 to the n plus 1 there. I'm just substituting n plus 1 wherever I see n. And that is over 3 to the n plus 1. Now that is being divided by 3 to the n plus 1. All right? Oh, excuse me. I'm sorry. Sorry about that. I'm rushing a little bit. That's being divided by the original series. N times x minus 5 to the n over 3 to the n. All right, so we're going to take that quotient. We're going to take that quotient, absolute value, and then we're going to evaluate the limit. So what we end up with here is the limit as n goes to infinity of n plus 1 times x minus 5 to the n times x minus 5, all right, which is the same thing as x minus 5 to the n plus 1. This is divided by 3 to the n times 3. That is being multiplied by the reciprocal here. That's being multiplied by the reciprocal, which would be 3 to the n over n times x minus 5 to the n power. All right? So what we're going to experience now is, like I said in the previous problem, a lot of cancellation. So here, that cancels. 3 to the n cancels. This x minus 5 to the n, that cancels. And now what you have is you have the limit as n approaches infinity of n plus 1, this here, over n, and you end up with times the limit as n goes, infinity of x minus 5 over 3. X minus 5 over 3. All right? And this is absolute value. Only 1 minute left. Oh, goodness. So this limit is 1. So what you end up with is, I only have a little bit of time. What you end up with is, for this to converge, the absolute value x minus 5 over 3 would have to be less than 1. You'd end up with the absolute value x minus 5. I'm sorry, I'm rushing. It's less than 3. It's less than 3. This simplifies to negative 3, less than x minus 5, x minus 5 less than 3. This simplifies, if you add 5 to both sides, you end up with x is in between 8, all right, and then if you add 3 or add 5 that way, you'd get 2 over there, and the middle of these two, would be, this is the interval of convergence. It's called the interval of convergence. The middle of these two would be 5. The middle of 2 and 8 is 5, so the radius would end up being 3. So the radius of convergence would be 3. I'm sorry, I'm over time. Forgive me. God bless you. Never quit in school. Always put forth your best effort. And remember, all students can and will dominate math. God bless you. Have a good evening.